Hello, happy Sunday. Sunday where I am, but happy whatever day of the week it is wherever you are. I hope you're having a great day and well. So what we're going to do today, we're going to take forward a little demonstration that we did previously. So if you want to look at that demonstration, please feel free to go and look at it. So what we did in that previous demonstration was we took an API that we didn't have the code for. We did have the code for. We didn't tell the AI. Don't tell the AI. So what we did was we fired up that API and then we went away and we said to Claude, we've got this API and we don't know anything about it. We've got no documentation. We've got no test coverage in terms of API automation tests. We haven't got access to the code, but we want to be able to reverse engineer how it works and create a new version of it. It's not that uncommon a task. And with a legacy application, you probably have the source code, which would make its life a little bit easier, but we don't want to make its life easy. We want to make its life a little bit harder. So we did that, and we did that by basically giving the AI extra powers using human being smarts to be able to give it capabilities to do various things. So we gave it the capability to basically interact with the proxy server so it could see all the traffic in real time. So that gave it an extra set of eyes. We gave it an extra set of eyes by being able to use an MCP tool to connect to an API and be able to fully understand the schema in a sort of syntax that a large language model can understand, and then have the capability within that for it to be able to make functional calls. Using that knowledge of the schema, it could build valid calls to be able to exercise the API so that it could actually probe it to be able to understand how it works. And we asked it to fully explore the API. On top of that, we also used some MCP tooling we created to be allowed to talk to a database. So we gave it access to that so it could also look in the backend database of the API to be able to see what was happening in response to those API calls and to look at the proxy traffic and to look at the database to be able to fully understand how that API works. So we did that. So let's say in this scenario now, we want to start creating a new version of this API, but we really haven't. We really want some API automation coverage. So we want to understand it. Or we've got access to the source code, and we still want to do business as usual, right? How many of us have been in that scenario? We're doing a greenfield version of A, but we need to be able to still work on A while we create B and add features to both at the same time. So that's not an unusual use case, and many of us have been in that world over the course of time. So we're going to show what we can use with exceptional human beings who fully understand how technology works. To leverage generative AI, you need to have the knowledge and the experience, and in my case, the decades of experience of knowing the development process, knowing the technology, understanding all the technologies, so that you can guide generative AI to come to a good outcome with the right technologies, and it's using those technologies in the right way. You need a good, experienced human being to be able to really do that. And that's what we're going to do in this demonstration. We're going to get it to backfill some API automation tests. Oh, we haven't got the resource, we haven't got the time, we haven't got the money to spend on doing that, but we want to do it. So we'll get the AI to do it for us. And I'll show you a whole set of capabilities that we can do with AI today. Where we'll create, add new features to these MCP tools to make them even more powerful using generative AI to do that at the speed of light. We'll get the generative AI to create whole new tools to suggest what tools would you need to improve what you're doing, and we'll get it to create those tools for us under our custodianship. So we can use this to hypercharge moving legacy applications to new platforms. That's not an uncommon use case in the modern world, right? We'll use it also to fully autonomously work with us away from the actual machine that's doing the work, and fully remotely be able to get responses from the AI when it's doing things, and us to respond back using our voice to be able to tell it to carry on and what to do in that particular scenario, so that it can work on these long-running tasks which may take hours or days till it gets to completion while we're doing other stuff, so we're not distracted unless it needs to speak to us. So we'll be doing some of that. We'll get it working on multiple repositories at the same time. That'll be fun. So that'll be fun doing that. We'll get it working on the front end and the back end of applications at the same time. Not only doing that, but we've already seen it with the API, using the API as a QA or a user to be able to exercise it as it's making changes to make sure those changes are working in the endpoint. Because as we all know, there can be things in the code it may miss, like middleware, that may cause issues in the actual reflected output as it goes through whatever that emission executable is that powers that output. So we'll be doing a little bit of that. If we're working on the front end, we could do the same thing with the front end. We can use MCP tooling to be able to get it to add features to a front end. Not only to add the features to the front end, understand how the UI works initially before it starts working on it, make the changes, then go into the UI and exercise the UI as a user to make sure those changes work. And to do that on the back end and the front end, on the API, on the UI, all at the same time to come to a completion. So those are all things that we're going to cover. But what we're going to do today, so we're going to look at this API that we created, and I created this purely for the purposes of another demonstration. So you can see there's a reasonable amount of code there. We're not going to give it access to the code. So we're not going to give it access to that code. So let's get rid of that. So we're not going to allow it to see that code. We're going to get it to backfill the tests by understanding how the API works. We could have given it the document we previously generated. We're going to get it to do that from scratch using some of the MCP tools that we used in the previous demonstration. Doesn't need all of them for what it's going to do. So we'll get it first to understand that. We'll get it to create a plan of what it's going to do, and then we'll see where we get to. So this is that API. I've shown it you before, so we don't need to see that again. So let's get Claude up, and then we'll make a start. So give me a second. So that's Claude. So we've got Claude running. So first of all, we want it to connect to the API. So first of all, let me just check it's running. Give me one moment. Please hold the line, caller. Your call is important to us. It is running, so let's get it to connect to that. So it's now going away. First of all, we'll see, has it got any tooling that's relevant to the request we've made, or will it just do it by pure inference? It will recognize it's got tooling to do that. It's now using the tooling to connect to the API. And this tooling does a lot more than just gives it a connection to the API. It goes away and gives it access to the specification of the schema that's behind what generates the Swagger UI. And then this allows the model then to understand how the endpoints work and what all the payloads behind the endpoints are. And therefore, using that, we've given it a functional endpoint where it can make calls to the API. So it can go away and make calls to the API as though it was a user, not using things like Postman, not getting a QA to do it, doing it itself to explore the API before it makes any changes. So it is now connected to that. We'll also get it to connect to the backend database to give it a bit more options about what it can do. So we've seen this tooling before, so we'll get it to connect to the database. So let's see if it can connect to the database, recognize it's got the tool, connect to the database. So off you go, see if you can connect, and we'll see in the response if it's successfully connected. So it's trying to connect. And then again, this not only gives it connection to the database, there's a little bit of magic that goes away and gives it information that allows it to fully understand the schema of the database. So we can see from the response that's come back, it's connected, and it's obviously connected to the database because it's told us some information about what's in the database. It also has toolings to go away and make functional calls against the database. So we've given it these capabilities, and that's all it's got apart from a little spec we're going to give it. So we'll give it the spec, and we'll just set it running. We'll leave it running. I'll just let it do what it needs to do. So first of all, we're going to put it in plan mode because we want it to create a plan, and then we'll approve the plan when we're happy with the plan, and then we'll let it proceed. So you'll see once I've pasted in a little spec for it, and you'll see that appear as soon as I press return. So basically create a new Visual Studio solution to create basically an API automation. We're going to be using SpecFlow for this. So this is basically a BDD sort of testing methodology that uses a syntax called Gherkin to create feature files, which is like plain English style syntax. And behind that, there are step definitions, which are the physical implementations of methods that make the tests. And then it has hooks to do things like run before and after testing to be able to do things. So we'll go and let it go away and first of all plan, and then we'll let it go away and do things. Really things we've really told it to do. We've asked it a certain number of technological decisions. So because this is actually a new directory I've created for this, I'm having to give it permissions to do things the first time because it's never been in this folder before. Brand new folder. I didn't want it to be able to access the source code. It's quite clever, and if the source code had been in the same folder, it would have gone away and found it, and then it would have gone away and used it. So we don't want it to do that because we want to make its life difficult. So first of all, it's going away, making calls against the API and doing various things. So it's just exercising the API to see how it works, to then come up with a plan about what it's doing. And it's going away now using the database tooling to just run some queries against the database to understand how that works before it starts making the plan. And then it will make a plan. We'll have a look at the plan, and then we'll set it running. So what we're going to set it running, obviously, normally we might put the API automation in the same repository as the actual application. We're pretending here we don't have the code. Don't tell the AI we've got the code. And we'll get it to go away and create a new API automation for us to be able to do this, because we really want an API automation, but we don't have the test time, we don't have the resources, we don't have the money to spend on it to be able to do that, but we could really do with doing it. So why don't we get the AI to do it at almost no cost for us, so that we've got that capability as well to improve moving this legacy application to a new technology. And that's what it's doing now. So it's now creating a report on its findings of the API, and it's going to then probably go away and create a plan, and then it'll start the implementation. So it's planning. So let's let it plan, and then we'll see what it does, and then we'll let it crack on. Pretty sure during the creating this application, it's going to be reasonably complicated. It'll need a little bit of input from a human. Luckily, I'm here. So I got your 6 AI, don't you worry. So it's made a little summary of what it understands about the API endpoints. So it's now creating a test automation plan so that it can go away and then actually do the implementation. So we'll let it create that plan. Probably want to think about that for a little while. And here we go. So here it has come up with a plan of what it wants to do. Basically create a HTTP client factory to use, define the spec flow features. It's come up with a more comprehensive implementation plan now. So create a Visual Studio solution, create a project, put the core technologies in there, create the spec flow features, and then do the test implementation, and then just some configuration stuff. So we'll let it proceed and auto approve edit. So off you go. So we're off. So at some point we'll see it starting to create files, I assume. That seems to be what it wants to do next. It wants to create a Visual Studio solution. So it heavily uses the bash command line for being able to do this. This is probably one of the reasons why Claude Code only runs on WSL on Windows at the moment, because it is heavily tied into how that works. And again, because it's the first time we're running this folder, initially we're going to have to approve all the permissions. If we'd done something in this folder before and we created a set of permissions, there would be a dot permissions Claude.md file, the .claude file that had the permissions in it, so they wouldn't keep asking us. So because it's the first time we run it in this folder, it's doing that. Okay, what's it doing? So it's creating a new class library by the look of it, which will be the home for the API automation tests. Off you go. So it's just doing some file machinations at the moment to get everything ready. It's creating a solution. It's adding the project to the solution by the look of it. So off you go. So we just move this window over here and we can watch it doing things in real time. I mean, dock for some reason. So we'll just do it manually. Okay, it's adding some packages. So it's adding spec flow packages, spec flow end unit, spec flow living doc plugin, SQL client, Newtsoft JSON. That all looks good. So let's let it do that. So it just wants to delete the noddy class 1.cs. So knock yourself out. So inside of here, will it dock yet? Yes, it will dock. So you can already see it's already gone away and created this folder structure for us. So it's created the project file. It's already created the folders for things like features, hooks, step definitions, which are all part of the spec flow framework. So it's creating a specflow.json. Don't know why it's created a connection string to a database there. It's not actually our database. So we'll let it do that. We'll probably see when it's generating stuff why it's wanting that connection string. It doesn't need it. So we'll find out as it does its stuff. So it's creating some DTO models at the moment for the various entities that come out of the API by the look of it. So let's let it continue. Now creating the HTTP client factory and the API client, which is going to use for making the functional calls from the step definition files, I assume. It's created the HTTP client factory. In the support folder. There we go. Now creating a client to consume that for the step definitions, probably to use that client to make calls. It's creating a database helper. I wonder if we can interrupt it at this point. I'm really interested why it wants that. Want to access the database, just the API. So we'll just interject at this point. deleting that database helper. So what you can see is not only is it's doing things, can it do things, you can interject and correct it as it's doing things, which is what we wanted to do. It's even tidying up the reference to the NuGet package. Very good, very good. I like what you're doing, kid. It's removing the app settings.config, which wouldn't have worked anyway. So it's now creating a test data generator helper. It's probably going to use that for using the post endpoints, is my guess. So it's creating a test context to track deliveries, and and we've told it to do cleanup after tests. So it's understood that we want to do that. So it's creating some of the infrastructure around that to be able to do that cleanup, which is very nice of it. Let's create a configuration helper, and probably just to pull the configuration from the app settings.json. It's adding the Microsoft Extensions configuration package to be able to do that. Good. Continue. Make some changes to some content that it wants to preserve in the output folder. We'll let it do that. It's now creating feature files by the look of it, so I'm assuming there's nothing in there. So it's now creating some feature files. So let's let it go and knock itself out. Get deliveries feature. So it's creating a feature file for that in Gherkin. So it's doing its stuff. Off you go. In the meantime, we're probably, we're in the cafeteria, having a coffee, maybe on the laptop, sort of watching this progress. Or if we'd set up the permissions, we could have let it to progress to completion. And you can do this. So you can enable something called dangerous permissions on this, where you can basically allow it to do everything it wants to do. And in that scenario, you generally run that, for example, on a virtual machine where you go away and, excuse me, let it complete what it needs to do and then inspect what it's done to make sure you know what it's doing. Now, I've shown you previously, I've got a capability in here where all the hook audit history is going to a hook audit file. Not just for auditing, but because I want to do various very innovative things with hooks to be able to do things with this. But as part of that, we can go and get the AI to go and do almost like a look at the audit history for this solution. Tell me if there's anything that I need to have my attention drawn to that we may not have wanted it to do. So we can do that, and we can also look at the code that's generated to make sure it's done everything that we want. Or we can just sit here and watch it do stuff. I mean, it's up to you. You pays your money, you makes your choice. It's now making the step definitions, which is basically the physical implementations of the C# that makes the method calls to be able to call the API. Well, it's done quite a lot here, so I'll be very surprised if this works out the box and doesn't require a little bit of human input to correct some issues that it may find as it goes along. So we're here. We got your 6, buddy. Don't you worry. Won't leave you hanging. So it's going away, creating step definitions by the look of it. It's having a bit of a think about that before it does anything. You take as much time as you like. I've got all the time in the world. Well, I haven't got all the time in the world. I've got things to do, but I'll hang around for a bit longer. So it's creating some common steps. So you can see that's just appeared in the step definitions folder. Now it's got a finite context window for making calls. And what you'll see is if it starts to run out of context, it'll do a thing called auto compaction, where it'll actually go away and it'll try and remove things that it doesn't think it needs to retain context of what it's doing to actually allow it to continue in that context. If you're doing things with Claude Code, it's very good to do something, do a functional thing, and then just clear down the context and start afresh. It's almost like wipe its brain each time. That's actually the best way of getting good outcomes with this, is don't let it confuse with the big context and auto compaction. Do what you need to do when you've done, break your tasks down into subtasks. When you've done your subtasks, clear the context, start again, move on to the next task. It's a very good way of leveraging this technology in its current format to be able to just don't let it get distracted or confused like a human. If you give it too much stuff to think about, it'll always look at stuff that maybe isn't relevant or get confused. So we like to keep the generative AI's brain clean so that it focuses on what we want it to do. And if it distracts or deviates from that intent, sometimes it's good just to stop it, clear the context, start again, and continue. So it's creating some steps now. You can see here some delivery steps, update delivery steps. So these are the functional implementations. It's using bindings, which is another sort of methodology as part of spec flow to be able to do that. It's decorated with a binding annotation. So we'll let it finish its step definition, which it's chundering through, and then we'll see where we're at and see if we can get to some point of running this. Now it's going to try and build the project, which is a great start. It's doing a .NET restore. Whoops, I'm in the wrong window. My bad. Let's do that. So now it's going to try and build it. See if it gets any compilation errors. If it gets compilation errors, let's see if it fixes them. So it's basically just restoring the project, the required packages for the project. It's now building, building, building. So it's got some sort of naming conflict. Okay, so it's created a test context class which conflicts with NUnit's default naming methodology. So it's seen that and it's going to go away and fix that by changing its naming convention. So to do that, it'll in the background it'll be grepping the files to go and find where they are, and then it'll go away and fix them. So you can see that's exactly what it's doing now. It's renaming that test context to test data context. So it'll probably have to do that in a number of places. We'll get rid of the folder now. We can carry on looking at what it's doing. So we'll probably have to change quite a few files. It's probably use that in a number of places. So let's let it fix what it's broken. It's now trying to build it again to see if that fixes the build error that it saw. It's been built successfully. It's now going away to create a README file to explain how the test automation works. How kind of you. Thank you so much. So it's doing that now. So what it's doing is it's analyzing the solution, either using what it's got in context and grepping the file structure where required. So this is the README file. We can probably go away and have a look at that while we're. Where did it put it? Just stick this over here. I'm just going to put it in here. I'm not sure where it's put it. It's created it. It doesn't appear to have put it anywhere. Okay. Let's just check in that it can talk to the database. And I should put it here. Of course it did. Let's create a README file explaining what it's done. Okay, so why don't you run the test? Well, let's get it to do that. So you can see here, it's created a nice little README file to tell us what it's done. Great. It's told us how we add new tests. It's told us how to troubleshoot it. Very kind. I can see in the console window for the API on another screen that it's definitely hitting the API quite heavily at the moment. Test run failed. Good, because I was expecting that. I want to see what they. It's now trying to. So it's found an issue with its test and it's going away and calling the API itself to see if it can replicate it. There we go. You see, um, it's doing that. I mean, what you can do with this as well as it's writing individual features, you can get it to basically run that API as part of the flow. I thought I'd hinted to that in the specification, but maybe I didn't. Maybe it was my bad. So it's going to fix the issue. So it's now creating a findings report by the look of it. So let's see what the report says, and let's see what we suggest for the API to do, the AI to do. There's only one P difference between AI and API. Okay. Now, not quite surprising. What it's done is, because we've thrown this API together, it's found issues with the API and how it perceives that the schema should work to how the API should work. That if we'd have gone away and reacted to what it suggested in its first analysis, when we did the first demonstration, it would have done that. In the interim, can we update the tests so they pass with how it currently works? And create improvements.md at the end so we can fix these later. So let's see what it says. So it's updating the failing test to match the current API behavior. Good. Now remember, we just threw this API together in minutes to be able to do a demonstration of cross-database technology, MCPs being able to do things. So what it's doing now is it's going to go and fix the test so it works with how it currently works, not how it thinks it should work from the schema definition. We've also told it to then go away and create an improvements.md file so that we could go away and fix this if we want. At the moment, we're on the assumption we don't have access to the code and we want to understand how the API currently works to be able to create a new version of this API. And then in that new version of the API, maybe that would be when we'd fix them. If we had the source code, maybe we'd fix them in the source code now. And then we'd use these automation tests to make sure that all the fixes work and get it to test those improvements to make sure that we've implemented them correctly. So it's going away and fixing the tests. Super happy fun times. So it's done one issue on its to-do list. So the next issue is some test data conflicts. It looks like the API will let it create duplicate order IDs. So we'll let it change the behavior of the tests to recognize the fact that that's how it currently works. And then in the last step, hopefully it'll create some improvements where we could go away and fix it in our next generation API. That would be great, wouldn't it? And probably what I'll get it to do once it's done what it's done is, let's go back to full screen now. We've read the README. It's taken us as long to read the README as it's taken the AI to do the whole set of work that we're doing because our eyeballs are too slow. We need to get one of these neural link plugins to the brain so we can keep up. Still making changes to the tests. Okay. It's now probably looking at the improvements. That's running the tests. Okay. You run the tests. The API window I can see on the other screen is going mental at the minute. It's obviously doing lots of things. It's found an issue. It's also using the tooling now to explore the API to see how it worked with that particular test to try and figure out why it didn't. You see, I'd have thought you'd have tried that, mate. It wants country as well. So it's going to update that. So what it can do is it not only can it write the code, when it gets an issue with the test, it's calling the API itself with what was the payload of the test. It's then looking at how the API behaves. It's inferring from how the API behaves why the test is failing. And we've told it we currently want it to make the test pass with how the API currently behaves. So it's doing all that. So make some updates to be able to insert these fully formed addresses by the look of it. It's now going to look at the update test, so it's calling that. Okay, so it's identified that the tests are running in parallel, the delivery is deleted before this update can happen. So we've got a race condition. It's figured out it's a race condition by being given access to the API and looking at what it's written. It's inferred, oh, hang on, why is this happening? It probably won't have seen that necessarily from the code. It'll have inferred it from how the tests are running, that what is a race condition that must be happening because it's, oh, I'm doing cleanup. Oh, that must be, I must have been relying on that record being there as part of that test and I've deleted it. So, okay, it's turning off parallel execution. That's fine. We could interrupt at this point and say, no, actually, we still want parallel execution to work. And we could give some instructions on what we want it to do that. So for the purpose of the demonstration, you turn that off, mate. You do what you like. I'm in your hands. You're the Captain Smith of my Titanic at the moment. So you've seen some business rule logics in the API. You cannot transition from pending directly to delivered. So again, it's making calls to the API as it's running the tests and it's seeing what the tests are doing and it's then fixing the tests in real time. Whereas what you'd be doing, you'd be writing the tests. Oh, let me test failing. Get me postman. Oh, I need to create a payload that was the same as the test. 3 minutes later, run the postman. Oh, yeah, that's it. Go back to your code, modify your code. It's done this in 20 seconds. It's gone away and done what you'd have taken minutes to do. So it's running the tests again. The API is going crazy, I can see. So it's still got 3 failures. So let's let it fix it. This is exactly what I wanted to see from this. So this is I haven't given it the source code, so it can't see how the code behaves. It's a poorly understood API. It's creating a full set of API automation tests. As part of that, it's understanding how, in addition to calling the API, as it did in our first demonstration, to document it. What you're doing here. Okay. It documented it, but it's never the same as running it, is it? It's why it worked on my machine, should always run it, right? To see it's working. And that's exactly what we're doing. So we're doing this at a much more accelerated pace to what we'd be doing. We'd be half a data a day in at the moment, writing this manually. So again, it's identified issues and it's exercising the API itself to try and figure out how it fixed the test to work with the API with how it currently works. Now, we may have given it a better chance of doing a better hit of this by giving it the more verbose, fully featured results from the first exploration we did on the other demonstration to give it a better fully formed specification of what it was doing. It did a pretty much minimal tickle at the start of this to be able to understand how the API works, and by giving it more information, we'd have had a better outcome quicker. But this isn't taking long, so carry on. We've started, so we'll finish, as they used to say on that famous quiz show that escapes me. What was that quiz show? I started, so I'll finish. Was it Mastermind? Maybe it was Mastermind. I'll name that tune in one, out something else. So, okay, it's running the tests. The API window's going mental. So it's definitely doing something. We're down to 1 failure. Call the police. So we're getting there. So let's see what it wants to do to fix this failure. I can see it's calling the API as we speak, so it's definitely doing something. It's calling the API again. It's not sure what's going on, so it's had to make another call. There we go. So what it's done is it's done multiple API calls to figure out what the missing field was, because we don't have any documentation on this API. We don't have the code for this API. So what it's done is it's called it multiple times to identify there's some issue with the missing field. Which field is it? Well, we'll just try them all till we find a response that works. So it's done that. I'm running the tests. Come on, you can do this. So it's still got an issue it can't quite figure out. So it's going to make the same call via the API directly. It's going to look at the response and then it's going to see if it can figure out why. Okay. It's another field it needs. So it needs the delivery date. I wonder how many more of these there are. Well, come on, you carry on, mate. You're doing all right. You're doing all right. I'm not going to vilify you for this. I'm going to support you. You know, we're It's not a blame culture we've got here with AI. We're not going to blame people. The system failed. The process failed. I'm going to support you. And I'm going to be, my natural modus operandi is positivity, right? I hate negativity with a passion. My modus operandi is any negative is a positive because it tells you something that went wrong so you don't repeat it again. So all the tests are passing. It's now going away doing our little improvement suggestion. So that'll be good, won't it? Let's see what improvements it's going to create for us, and then we'll go to create some kind of test report. We're just going to stay in Claude. We're not going to go near Visual Studio. We're just going to stay in Claude so that as though the AI had done it itself. It has done itself with a little help from its friends. This will get very interesting when I show you the things we can do where we can do this, where we're doing other things, we may be even away from the PC. I'm going to blow your mind with the things that we can do with this. But again, I'm breaking you in gently. So we're riding one horse on another horse's back just to break you in gently. So we've got an improvements MD. So let's see if we can find that, because that'll be nice, wouldn't it? There we go. Oh, cheers, mate. So here we are. It's creating a full documentation of issues that it thinks with the way that the schema is defined and how the API works. It's discovered as it was writing the tests. So you see, we've understood so much more about this legacy API. By creating a report where it exercised it. The value of these API automation tests isn't necessarily going to modify this. We fully understand how it works. We can give it that original document. We can give it this document, and we can get it to go away and merge these together. We can do lots of things. So, can you list a report with the test scenarios and their passing status? Need one for the boss. I wonder if it'll respond with a bit of humour here. That would be nice. I could do with a laugh. I can see the API is going ballistic, so it's doing stuff. It's running the tests. Oh, let me create a fresh test report for your boss. Oh, my boss is going to be so pleased with me today. Let's see what it generates. I'm looking forward to seeing this. It's test execution report.md. I'm going to wait till it's finished. Okay. Execution. Okay, we'll have a look at it. Let's have a look at it. And here we've got the test execution report. So let's cover all the test cases, all the scenarios within those test cases, and it's given a full test report of everything it's done. So if you do not understand the power of generative AI with experienced humans to be able to completely transform the development process, you need to become a plumber, because this is obvious to me. And if it's not obvious to you, then you've got a problem. Now, to be able to survive in this industry, you're going to be able to not only use the vanilla technology out the box, you're going to need to orchestrate it. You're going to need to empower it. You're going to need to take it to the next level, because otherwise you're not going to be here. I love doing what I'm doing. I'm passionate about what I'm doing. I spend a lot of time doing it. And that's why I've spent a lot of time over the past 2 years. I've seen the pivot coming. I've got ready for it. I'm ready for it. So I'm already got my head in gear to what I need to do, because I've already built coding CLIs. I've had coding CLIs for years, ready for when the technology surpasses what I've got. And to use all the implementations inside those CLIs, they're all ready to go. I can now put them in there, and we can start taking this technology to the next level. So I hope you enjoyed that little demonstration. That was just a bit of a rainy Sunday, so I thought I'd carry on and bang another one out the door while we're here. So I hope you enjoyed that. Have a brilliant rest of your day. Look after yourself. Take care. Speak to you soon. Bye-bye for now. Bye-bye.